HTTP responses is a fundamental component of the Hypertext Transfer Protocol, HTTP. But what are they? In today's show, we're going to discuss what they are and why every developer needs to learn how to use them. We talked previously about HTTP responses. Sorry, no, we didn't. We previously talked about HTTP requests and how requests are constructed. The HTTP response is equally as important as the request, as it tells the client how the request was handled. So the request tells the server how the response should be handled. The response tells the client how it was handled, okay, after the fact. There are 10 reasons why HTTP responses are vital. And these are the 10. All right. The first one, a HTTP response. How is that word so difficult? It's not even a word, that acronym. A HTTP response holds status information regarding the communication between the client and the server. So this is information that could include things like the time in which the response was made, who made the response, where did the response come from. It's also got status information such as, did this response fulfill okay? Did this response succeed? Are there any issues with this response? Is this response valid? The second one, HTTP responses can hold data or content that has been requested by the client. So, a response may, depending on the type of request, I guess, the response may contain a payload, such as JSON or XML, a data payload, or it could contain, say, an information about an image, or it could contain a PDF, or it could contain anything really. You know, it contains data or content that has been requested. So when you make a request, you say, hey, I want this thing, right? And when I say this thing, I'm saying, hey, this resource. I want this resource. Or I want to do something to that resource. And the response will either go, no, you can't do that. You need this. Or it's going to say, yeah, fine. And then this is the result of that request, right? Okay, so number 3, errors are also reported via status codes and messages. This is where a lot of people get things wrong because they muddle up all the error codes. You know, the amount of times I've seen APIs fail and yet come back with a 200 OK. That's not okay. That's a failure. Or they've returned a 500, but it should have been a 400. Or if the resource isn't found, we get a 200 OK, but with a message, a human readable message in the JSON payload saying cannot find page, and yet it's a 200 OK. So you need to learn the responses. You need to learn the codes for those responses, and you need to make sure that you're actually putting down the right HTTP response codes for the actual thing that you're responding to. Okay, so let's say, for example, you have been requested so you're the server and the client is requesting something to you from you, and it's providing you a series of maybe data in perhaps a query string, or maybe it's a post, and so it's providing you some data in a payload in JSON, and yet you are missing some of that, right? So the server does some validation and it's actually missing, say, the ID of the data that you want to change, right? So what do you do with that? Because if you don't validate that, it's going to blow the server up. It's going to return a 500. That's not good. That's not good. That's telling the client that there's an internal server error. What you need to do is handle those things, and that should actually be, say, a 400 if it's missing or it's got invalid data. So a 400, invalid data, an invalid argument has been supplied. If they are requesting something that just doesn't exist, then you need to return a 404. So that's a resource cannot be found. It's very important. It's incredibly important to make sure that your HTTP status codes are correct. It's also equally important to make sure that the success codes are correct as well. 200 versus 201. All right. It's really important to make sure that they're correct, as well as the redirections, 301s, 302s. Make sure that they are correct as well. If you don't know what they are, please do look them up, and I'll add some links to resources in the article of where you can look up these status codes, right? But once you have knowledge of these status codes, it really does change the way in which you write your responses, because you are checking for these various things and you are responding to them in the right ways, which means that the client can alter its behavior based on the response and the right response. If you just assume everything's a 200 okay and then you're just relying on this human message that says whether there's errors or not, then that's ridiculous. You need proper error codes, static error codes that don't change, that have an actual meaning and definition. I get so wound up, as you can probably tell, when I'm dealing with APIs, and it's like, why did I get 200 okay when it's not okay? This is far from okay. The bloody thing doesn't even exist. And I can see it because it says it in the message. This does not exist, but I've got a 200 okay, which means that my app has just assumed that it's worked. So your API client, which is on the front end, or whatever client you're using, needs to then take these HTTP response codes and do something with them. All right. Change the behavior based on the response codes that were given. So it's a two-way thing, right? So your client needs to work well with the HTTP error and success and redirection codes. Okay, so they need to be aware of what those are. Okay, so the next one, where we're starting to fall down and into more of the weeds a little bit, is that the response itself can contain headers that are used for caching strategies. This is pretty awesome, because with caching strategies, you are able to tell you're able to say that this is cached and this is cached using these kind of things. Whether it's like gzip or something like that, and you're able to tell the front end that you don't actually have to request that again, or this expires, after a certain period of time. So you don't need to deal with that anymore. Responses can redirect the client to different URLs. So if, for instance, for example, I'll use the example of the tutorials and the articles on the howtocodewell.net site. There were a couple of articles that used to be tutorials, but now they're articles. And I know that they've been crawled, which means that when I get a web request to a tutorial that doesn't exist, I could tell the crawler or whoever is accessing that page that instead of returning a 404, say that this has permanently been redirected to another page, which means that next time they touch it, they know that it's actually going to go to the new page rather than the old one. That's a really great way. So, for example, if you're changing your URL structure using the right HTTP error codes or redirection codes, status codes, is a great way to tell Google and other web crawlers that you're manipulating and changing the URLs. You're changing the structure of your URL, shall I say. And these are the new URLs. This is what we're going to redirect to. So it's a great way to check that. And yes, over the coming days, I'm going to have to write something that will bounce certain URLs from tutorials to articles and vice versa. I am aware on the howtocodewell.net there are a ton of URLs that no longer exist because I have literally changed everything. So I am forever looking at my 404s going, I at some point, one day, I need to have something that catches those and puts them in the right place and has some mapping strategy to say that is actually going to this page now. Yeah. But that's a rainy day thing. That's a rainy day thing. Okay, so the number 6, security headers can also be included in the response, which are used to mitigate web vulnerabilities. Okay, so we can have security headers, like we have headers in our request, we can have headers in our response, and we can even create our own headers if we wanted to, and we can use those headers to mitigate certain security risks. It's really important to understand that a response isn't just something that you throw JSON at and just say, there you go, Laravel response, and then pass in an array, off you go. There's far more involved, or a response can have far more than just a payload. You can actually tweak the headers and actually add some headers and manipulate the headers and whatnot, and then from the client you can capture those headers and do things with them. So that's really cool. The response can indicate if a request is authorized or forbidden. So still on the security theme here. So we can actually say that this request is authorized, or it's a 403, which is a 401. So it's an unauthorized, or a 403, which is forbidden. So the difference there is that a 403 doesn't say that the thing doesn't exist. It's saying that you don't actually have access to it. It's forbidden. It's forbidden. Whereas a 401 is saying that you have access denied to this resource, right? So again, another example of where you can use status codes to tell the client why and how to access the URL, the server, right? You can't access this page because you're not authorized, or you can't access this page because yes, you've logged in, but you're forbidden. You don't have the right privileges to access it. Okay, so headers such as expires and cache control can reduce the number of round trips made for data retrieval. We touched on this earlier, but this emphasizes the fact that your HTTP response can say that, hey, this image that you've just downloaded, or this JavaScript file that you've just downloaded, cache it. It's not going to change. It's not going to change until perhaps the next deployment. So cache it. Don't keep retrieving it all the time. Which means that your future requests are going to be smaller in size, right? And also fewer in frequency, because we don't need these things. They have an expiry date on them. And we're controlling them via certain caching mechanisms. The 9th one here is that cookies can be set or managed through HTTP responses. This is really important. These are used to maintain user sessions and allow user tracking. So with a HTTP response, you can say, hey, create this cookie, or manage this cookie, and then we'll maintain this going forward to the next page. So your user session can be it is still active on the next request and on the next request, and this is used for user tracking in certain places. And then the last one here is dynamic websites that are built using JavaScript and Ajax can use JSON and XML payloads to reload certain parts of the page without reloading the full page. This is fantastic. This is one of the many things that really got me excited about getting into web development is Ajax in the early days, because you are able to request things from the server without actually having the need to do a full page reload. So back in the day, when we were all creating, you remember hit counters and guest books and all of that stuff? Oh, I'm going to age myself now. Where you would hit a page and you would refresh it and you would refresh it and you refresh it and the number would go up. your hit counter would go up. Well, you could also do it so it's not actually, you don't actually need to refresh the page, right? So you just click on it and the number of seconds, right? It counts the number of seconds, and then you can press like a stop button and it stops. Refresh the page and it's still on that number of seconds. What you're doing is you're doing a hit counter, but you're basically counting time, essentially. And you can do like a start stop. It was pretty fun back in those days. But now, of course, we're using this for far better things, especially around single-paged applications, where we're not actually allowing the user to change pages, because there isn't technically a page to change. It is just, this is your single-page application, your PWA, and it is a means of encapsulating the website or the application within a quote-unquote app, and the buttons that you're clicking, they're actually sending requests off to the server, which changes the interface based on what you're doing, of course. But it is essentially just firing off HTTP requests, and then the client is changing the interface based on the responses. That's essentially what that is, to be honest. But yeah, I mean, HTTP responses are so important to understand, and it's one of those things when you start learning to code, it is one of those things. It's like, oh, I know how to make a request and I know how to make a response, and that's all I need to worry about. I make a request to this page or to this API, done. And half the time, when you're learning to code, you don't even worry about the fact that you can cache things. You don't worry about how to have authorization. You don't worry about how to use AJAX. You don't worry about all the various things that you can do with a HTTP response. It is just sort of, you make that request and you get the payload back. Done. And there's no need to worry about, say, that's a 200 versus a 201. It's when you get later into your career, or even just learning development, then you really start to unpick what these things actually do. And then, of course, when you start working in the industry, you really need to know what these things do and why these things are important. Because if you write your application without this kind of knowledge, then you're going to be in for a world of pain, especially when you're screwing up the HTTP response codes, when you're mixing the error codes, or even mixing the success codes with the error codes. That's just painful. Please don't do that. And please don't rely on human readable messages. Yes, you can have human readable messages to display to your app, but personally, the way I prefer and the way I've seen it done in so many applications, which is just so much better, is to have on your API client, have a list of error messages to be displayed. It's then up to the client on how to format those and how to word those. Your response, your HTTP response, will have the error code that will be mapped to one of those human readable messages of the client. Now, that can be quite abstract, because you might be wanting to have your client have a message that is more geared towards perhaps the resource or the process that was a request at the time. And so having something that is very generic is probably not good. So something that I've seen happen a lot is have, say, internal error messages that that can be mapped to the client. So, for example, you may have a 404, right? So let's use the howtocodewell.net site, for example. So I want to request a tutorial, and the tutorial doesn't exist. So I'm going to return a 404. Now, I could return a message with that 404 to say this resource doesn't exist. And then I could use that on every single piece of content on the howtocodewell.net site. So the course doesn't exist, the podcast doesn't exist, the tutorial doesn't exist. From the mapped point of view, it would just be the resource doesn't exist. That's what's coming back from the response. It's a 404 error code with resource doesn't exist. That's the human readable message that comes back. Or what I could say is something like tutorial underscore not exist. So tutorial underscore not underscore exist as the human readable message with the error code of 404. I can then pick up what that is from the front end, from the client. I can say, oh, it's a 404, and the internal message, error message that we have is tutorial underscore not underscore found or something like that. And then I can then map that to some error message that the client has defined, which means that I can then change that from the client's point of view. I don't have to worry about changing it from the response's point of view. This is something that I've seen quite frequently. You're saying that you're giving more context to the error from the point of the response, but you're not allowing the response to dictate what that human readable message is. The other danger of having human readable messages coming from the responses is that if the response is broken, then you need to handle that, right? So if it's coming back with actual error message, I've seen this before. So the human readable message is actually the error that you see in the log files. No, don't do that. And I've also seen it so where the client will decide whether to show that to the front end or not, depending on whether you're in dev mode. No, don't do that, please. Don't do that, because you're exposing stuff to the front end and you really don't want to be doing that. So having some form of, it's a linkage between the API client, which is the front end, and the server, saying, hey, this was the error, it's an error 404, and then this is perhaps a message that has a little bit of context, but it's kind of like an internal message that both the client and the server are aware of, and then it's up to the client to then decide how to format that. And that, I have to say, works fantastic with translations, because let's say you've got an application that is translated in various different languages, where you're going to need some form of internal code, the translation, right? And then the client is going to decide how to translate that internal message.